I'm playing the video.
Okay, here we are again. I'm live here with Jamil Saman from Canela Software.
Hello.
He's going to tell us about using behaviors and something called the Postmaster technique. Is that right?
Yes, it's a programming technique, and basically today's talk is going to be on how you can use some of these different techniques to make your LiveCode application behave, no matter what kind of application it is. And it's presented in a video format because there's a lot of content, so it might be helpful to review later on when the video becomes available. But yeah,
Great.
I'll have time for questions after the video plays. Without further ado, let's get started. Okay, push load video. And LiveCode is a great tool for creating exciting mobile and desktop software. As expected, when an application grows in terms of features and content, it can become more difficult to manage. A UI-heavy application could potentially end up with code spread across many objects spanning the entire project. Today's presentation will discuss techniques that allow more centralized control of any LiveCode application. We will go over behaviors, Postmaster programming, and script-only stacks. Implementing any of these techniques will benefit the control of any LiveCode application in some way, but when used together, they can very effectively make any app behave. Understanding how to use them together requires looking at each on their individual merits. The first major technique to discuss is the use of LiveCode's behaviors. Behaviors are a simple concept on the surface. They are just properties of LiveCode objects. More specifically, an object's behavior is a string which directs it to the script of a different stack or button. The result of setting an object's behavior is that object inheriting the script of the stack or button being pointed to. The easiest way to set the behavior is to provide the long ID of the stack or button with the desired script, because LiveCode knows how to convert long IDs to the exact format seen in the behavior property. So what are the benefits of using behaviors in your LiveCode project? One clear benefit is that behaviors allow a single script to control many objects. For example, a behavior script could contain custom functions or common event handlers that are necessary for multiple cards or UI elements. Instead of spreading code across different objects, a developer can write a single script with all the necessary code for each. Using behaviors also enhances the modularity of your app. It is easy to add and remove a piece of the app without breaking the whole thing when the piece's code is neatly contained in a central location. This leads into the fact that having a central location to examine also speeds up the debugging process when an app behaves incorrectly. Similarly, adding new features to an app is simplified by having a central location to add the necessary code. In order to understand how you might use behaviors to enhance your own applications, consider this sample stack X. It's a very simple stack. It just contains two cards. One of them is card A, the other one is card B. And card B also happens to contain button C, which, when clicked, shows a pop-up dialog that indicates button C received the click. Suppose that we wanted the same thing to happen when the user clicked on card A. Currently, clicking on card A does absolutely nothing, and that's partially because the script of card A contains absolutely nothing. So how would we go about solving this problem? One potential solution would be to add a mouse up handler to card A's script. However, this is unnecessary. We've seen that the logic we're looking for is already in the project. It's in the code for button C. And furthermore, if button C's mouse up handler happened to be complicated, bringing it over to card A might result in copying or rewriting many more lines of code than are really necessary. Behaviors allow us to achieve our goal using exactly one line of code. And furthermore, because behaviors are just the properties of an object, setting them is just as easy as setting, for example, the width or height of the object. All we have to type is the following line. Set the behavior of card A to the long ID of button C of card B. When that line executes, the result should be that clicking on card A does the same thing as clicking on button C. Shows this pop-up dialog. Let's go verify that. We click on card A, we can see that the pop-up dialog shows that we've clicked on card A. There are a few interesting things to note about what we just did. One of them is the fact that card A's script has not changed at all. We have done nothing to it. If we open it again, we can see that the script is completely empty. The other thing to notice is that when we click on card A card A appears in between those brackets instead of button C, and that's because of the use of the me keyword. In LiveCode, when you use the me keyword in the script of a behavior, it does not necessarily reference the original owner of the script, but rather of the currently executing object. So we click on card A shows up. We click on button C shows up. Finally, to further hammer home the point that we really have done nothing to the script of card A, let's see what happens when we manipulate the mouse up handler only in the script of button C. We're not touching card A. Let's add another pop-up which reads second message. We save and apply it, and we can see that the effects are also seen when we click on card A. Even though we did not touch card A, we only touched button C. That's the power of the behavior. It allows the developer to consolidate the code for many different controls all in one place. And if we want card A to not exhibit this behavior anymore, it's just as easy as it was to set it. All we have to do is set the behavior of card A to empty instead of to the long ID of button C. When we do this, and we go back to card A, clicking it does absolutely nothing. The behavior property is a very robust tool in LiveCode. But there are some considerations to keep in mind when using it. Consider again the example we just worked with, stack X. In that example, we set the behavior of card A to point to the script of button C, and as a result, card A effectively inherited button C's script. A visible consequence was that clicking on card A triggered C's mouse up handler. However, card A's script was empty throughout the example intentionally. If card A also happened to have a mouse up handler of its own, it would have executed before button C's. This is because when LiveCode looks for message handlers, it considers an object's own script before considering the object's behavior. This caveat actually managed to make its way into the demo. A keen observer may have noticed that each card of stack X contained a button that switched cards when clicked. Even after we set card A's behavior, clicking on the navigation button did not display a pop-up. This is a direct result of the navigation button having its own mouse up handler. Because the button did not pass mouse up, the message never reaches button C's handler. If we want a pop-up to display when that button is clicked, while also preserving its original functionality, we have to add pass mouse up to the end of the button's handler. Passing the message would give it to card A, and because card A has no mouse up handler of its own, the handler in button C would end up executing. This solution relies on making sure different UI elements fully understand how to handle their respective LiveCode messages, which may not scale well in a large application. This is akin to, for example, the Postal Service trying to make sure that each resident in a neighborhood understands exactly how the mail delivery system works. The result would be far more room for delivery error and more burden on the residents. In the real world, that is why something or someone called a Postmaster takes care of most postal operation. A resident's only job in that system is to act as a sender and recipient of post. Postmaster programming models that real-world structure in the context of LiveCode objects and the message path. Instead of several buttons maintaining their own mouse-up handlers, a single script contains a mouse-up handler which acts as the postmaster and handles all the logic for each button. The benefits of using this technique in a LiveCode application are straightforward. Having a central script handle the logic of common messages eliminates the need for any other object to hold code, making the application more reasonable to keep track of as it grows. Apps utilizing Postmaster programming also lend themselves to modularity, because they provide a well-defined structure for developers to modify UI code. A script designed with Postmaster programming leaves clearly defined room for the addition and removal of event handling code for UI elements of an application. Furthermore, Postmaster programming is a natural fit for behavior scripts, because behaviors set up a clean structure for all the messages from different LiveCode objects to land in a central location, and Postmaster programming sets up code made to handle all of those messages from that location. To get a taste of the power of Postmaster programming, let's return to stack X. It's just like we left it before. Looking at the project browser for this project can tell us a couple of things about it. The first and most obvious is that card A does have a behavior attached to it. This is indicated by this little oval, and when we click on that oval, the script for button C appears in the script editor, and that's because that script is the behavior script of card A. The other thing the project browser tells us is that the code over the whole app is spread across a few locations, the navigation buttons in each card, and button C. If we open the scripts of the navigation buttons, we can see that it's a simple go card statement, because their only purpose is to navigate. Button C's code we've already seen before. The theme of the last demo was to consolidate the mouse up behavior between button C and card A. Since we wanted them to behave the same, there was no point in duplicating the code in card A and needlessly having the code spread between card and button. However, Postmaster programming allows us to consolidate these unique mouse up behaviors of these two buttons and card A and button C all in one file. We're going to accomplish our goal by writing a new command, and this command is called Postmaster mouse up. It's going to have one local variable called tTarget, and tTarget is going to contain the target of the user's click. So we're going to type put the long ID of the target into tTarget. Next, we're going to use a switch statement to execute specific logic based on what the user clicked. So we're going to type switch tTarget. We need to think about which cases to handle. The first case is the user clicks on button C. So the first case we're going to write is case the long ID of button C of card B. The next case we need to handle should execute the exact same logic, and that's clicking on card A, because we want this pop-up when card A is clicked. So without putting a break in between, we're going to add the statement case the long ID of card A. The next two cases are for the navigation buttons. So we're going to type case the long ID of button left of card B and a break, and then we're going to type case the long ID of button right of card A. Now that the skeleton of our method has been set up, all we need to do is fill in the gaps. And luckily for us, this app is so simple that filling in the gaps is not difficult. For clicking button C in card A, we're just going to take this answer dialog and copy it right into the code, like so. For the navigation buttons, we need to put the appropriate go card statement. So from card B, we need to go card A, and from card A, we need to go card B. Now the method is completely in place. We're going to take out the code from button C's mouse up. It's no longer needed. We still want all the mouse ups to route to button C, so we are going to add a line of code which just calls Postmaster mouse up. Next, we're going to remove the mouse up code, and all the code for that matter, in the navigation buttons, because we don't need it anymore. Finally, the last thing to do is set the behavior of card B, because last time we didn't set the behavior, and we want any clicks on card B to also get routed to button C. So we're going to execute this line in the message box, and now card B has the behavior. And now everything is set in motion. The only place where there's a script is button C, and it has Postmaster code to deal with a mouse up. Let's verify that everything works as it should. Clicking on card A shows the pop-up. Clicking on the navigation navigates between the cards, and clicking on button C also shows the pop-up. We have shown that Postmaster programming can be used to consolidate unique behaviors between UI objects into one file. That way there's one central location to debug, add, or remove code. Let's say we don't want the pop-up to happen anymore when we click on card A. We can simply remove this case, and we're done. There's nothing else to do. We didn't even have to remove the behavior this time. And let's say we wanted the pop-up to happen when we clicked the navigation button on card A. We could add answer going to card B. And now that we've added that, when we click on the navigation button in card A, it says going to card B before actually going to card B. And furthermore, clicking on card A no longer does anything. Using Postmaster programming created a true central location for the mouse-up handling of every object in stack X. Because X is a simple tutorial stack, Postmaster mouse up is not a particularly long handler. Considering the scenario where X becomes a larger application and requires more logic, should make it clear that the handler could become significantly longer to the point of the switch statement being difficult to read or navigate. This is partially due to the fact that switches and other conditional structures grow linearly with each possible case. Postmaster programming is not just about creating rigid switch statements or conditional blocks. It's more about the concept of providing a single landing spot for the handling of LiveCode messages. Those messages may best be handled in separate handlers, making the Postmaster's job to properly route messages to the right handler. The final technique to discuss is using script-only stacks in an application. Script-only stacks are just that, stacks with nothing except their script. They have no cards or UI elements. An important feature of script-only stacks is that they are viewable as plain text in any text editor. This also means that version control software, such as GitHub, can read the scripts to display direct comparisons when a project script changes. Despite the simple concept, it can be beneficial to use script-only stacks to organize an application. Though they are additional files on top of the main binary stack, they are more lightweight than any binary stack with the same amount of code. They allow for modular design in a very visually obvious way. As separate files, they are mostly independent blocks that can be deleted, changed, or even shared with ease. As mentioned earlier, they are well suited to version control. As plain text files, they are easy to read and compare. In large-scale applications worked on by teams, it is priceless to have these kinds of visual comparisons to versions of a script multiple people worked on. Perhaps most importantly, because behaviors can point to other stacks, script-only stacks can be used to contain behavior code. Combined with Postmaster programming, that would mean an application could have its UI completely controlled by script-only stacks, leaving very minimal code left to be managed in the main binary application. To demonstrate how to create and set up script-only stacks, let's return to stack X one final time, where all the code for the application has been consolidated into one spot, the script of button C. Though this is well designed in the way that behaviors on Postmaster programming have been used to put all the code in one place, button C is not the ideal place for this code to be. If a user of your application requires an update where the only change was to that script, instead of getting an update for a separate file containing that script, they have to get an update to the entire binary application. We could lighten the load on the user in this case and make the app more modular using script-only stacks. Creating a script-only stack is just like creating any other stack in LiveCode. It requires clicking on the File menu and hovering over the New Stack option. However, instead of clicking on any of these sizes, you want to click on the option for Script-Only Stack, which brings up this dialog that asks you to enter the name for your stack. The name of the stack is going to be Mouse Behavior. Clicking OK brings the empty script of our new stack into the script editor. The first thing to do is copy the code from button C into stack Mouse Behavior. I'm going to save it on the desktop. The next step is to make the script-only stack and the binary stack work together, but not before removing the code from button C, because it's been moved into a script-only stack. First, the script-only stack has to be loaded into memory, and then it has to be set as the behaviors for cards A and B. We're going to accomplish this using a pre-open stack handler in the script of stack X. Script-only stacks cannot be used as standalones, so we still need to write this code in the binary stack because that's what would be built as a standalone in the actual application. So first we're going to type on pre-open stack. Ideally, the script-only stack would actually be somewhere centrally located next to the application or in some special folder. But because in this example I just put it on my desktop, all I have to type is OpenStack special folder path desktop. And then I'm going to add a slash and mouse behavior dot live code script. Now we're going to add some error checking to make sure that it opened in memory correctly. So we're going to type if there is not a stack mouse behavior, then we're going to throw an error message and exit the handler. If everything went well and the stack is actually in memory, we're going to set the behaviors of cards A and B to point to this stack. We have to type set the behavior of card A to the long ID of stack mouse behavior, and the same line for card B. We also want to be very careful about our pathing, because if we don't specify that these are of stack X, LiveCode may not recognize where these cards come from and throw an error, and that's an error we want to avoid. Additionally, just to be safe, I'm going to encapsulate the long ID of mouse behavior in parentheses. In order to verify that this code works, we're going to temporarily close LiveCode. But before opening it again, I'd like to highlight a couple of key features of script-only stacks. The first of which is that they truly are text readable. If you open it in a text editor, such as Text Wrangler, the script is just as visible as if we were reading it in the LiveCode script editor. Another key feature is that script-only stacks are lightweight. If we look at the file size of this file, we can see that it's only a matter of bytes. And that's really currently because we haven't written a lot of code in there. But even if we have written a lot of code in a script-only stack file, that file is generally going to be lighter than an equivalent binary stack file. So, despite the fact that you're going to have to load script-only stacks into memory every time your application runs, they're really not large files to load into memory and shouldn't impact the performance of your application. Now let's verify that the application works as intended when we open it again. So we're going to open the main stack file, not the script-only stack. The script-only stack is not something that can be used as a standalone, and it's not what we're opening here. We're opening stack X, and we can see that there were no errors, and clicking on all the buttons has the expected behavior we were looking for. Although interestingly, if we go back to button C, when we click on button C, no longer does button C appear in those brackets, and that's because button C is no longer the currently executing object. Because button C no longer has a mouse-up handler, the message gets passed along to card B, which executes its behavior script. But other than that, everything works fine, and if we open the project browser, we can see that there's only code in mouse behavior in stack X. A and B have behaviors, and those are stack mouse behavior. And button C, even though it says 22 lines of code, they're commented out, so in fact, we can take those lines out. In that example, button C's behavior code, which controlled the UI of stack X, was moved into a script-only stack. Though this allowed us to remove the UI controlling code in the binary stack, it did introduce the new consideration of loading the stack into memory before being able to use it, since it was in a separate file. Despite the level of control mouse behavior had over stack X, there is no way to completely eliminate the existence of the binary stack. Script-only stacks cannot have any UI of their own, and most importantly, cannot be used as standalones. Trying to build a standalone out of a script-only stack is not likely to work. Naturally, as an application grows larger in scale and needs more than one script-only stack to manage its UI, the developer inherits more pieces to manage, such as remembering to load all of the stacks into memory and assign them as behaviors to the correct places if necessary. Finally, they are readable by anyone, whether that person uses the LiveCode IDE or not. It is worth keeping in mind that under normal circumstances, the potentially crucial code in a script-only stack is easily readable. Overall, behaviors, Postmaster programming, and script-only stacks can each be used on their own to enhance any LiveCode application structure in some way. But more important than their individual merits is that when used together, they can completely control how your app behaves. Behaviors allow any number of LiveCode objects to point to one script, and Postmaster programming grants that script the ability to handle almost every message sent to it. Script-only stacks are logical locations for these robust behavior scripts. The steps we went through to control stack X from a single script-only stack are the same for any application. The only difference is that a larger app will have more Postmaster code to write, and likely more than a single script-only stack to control the application. For example, Canela's sample database app, Contacts, is more feature-rich, but utilizes the same techniques so that the app is controlled from two script-only behavior stacks. Its setup to achieve that structure is not much more complicated than X. The behavior scripts simply have more code inside as needed. My hope is that all your applications will benefit from implementation of the techniques discussed today.
That was great, really clear. Thank you, Jamil.
Well, thank you. All right, so I'm open now to any questions anyone might have about the topics discussed in the video.
Let's see if we get some. Yeah, I believe you mentioned that that everybody's going to get the stack and the script and the that you've shown there. So
Yes.
We that round afterwards.
Yeah.
Some comments there. Good presentation it was. It was very clear. I liked that.
Well, thank you guys.
I think you did it too well. They don't have any questions. Yeah, it's very neat that you can have these behaviors, or indeed, I've never heard of Postmaster programming before. You see, I don't, I only help people. I don't program myself. But I thought that's very clever. It does make a lot of sense. You can just have one thing that controls everything. It's good.
Yeah. Keeps
Mike has a question for you. There you go.
So to answer Mike's question, depending on the license you have of LiveCode, you can actually encrypt script-only stacks the same way you can encrypt any other stacks. You're able to do that. But I believe there's a property of a script-only stack called script-only that you have to set to false for it to be encrypted. And then that way the end user won't be able to see the stack that you create.
Kelly Jans is asking, is this Levure Light?
What is Levure Light?
Okay, so Levure is Trevor's framework that he demoed earlier in the series. I don't know if you've come across it. It's a good way of version control and various other things. It's a bit like this, yeah.
Okay.
Yeah, but obviously a lot deeper and more complex. So yes, I think Kelly, I think it is.
All right.
Oh, and that was Clarence's question as well.
All right.
Great. Well, brilliant. Well, you've done that very neatly, and you're actually within your time as well, which is nice because we've had quite a few people overrun today.
Oh,
but done that well.
Can you go over? So a script-only stack is just a stack. So when I said in the video under normal circumstances, that would mean like you didn't do any special encryption to the stack. If you have an unencrypted binary stack, the user would still have to have the LiveCode IDE to open it and view it. But an unencrypted script-only stack, you can view in any way. To encrypt a script-only stack, I believe it should be the same as encrypting any other stack, except you have to switch the property of the stack that says script only. You have to switch that property to false, and then you should be able to encrypt a script only stack.
Yeah, you would just use the encrypt functions that you can look up in the dictionary, Clarence, I expect. And yeah, that makes sense.
The stack that is going to go out in, whenever it goes out, it's been slightly changed from the one in the video in that the app is not going to look for the script-only stack on your desktop. It's actually going to look for it in the same folder location as the main binary stack is. Kind of more, I think, a more logical placement than the desktop. The desktop was just for the purpose of the video.
Cool, great. All right, well, thanks very much, Jamil.
Well, thank you.
I'll come back here. So, yep, we've got the very last session of LiveCode Global coming up for 2017, and Richard is going to present it, our community manager, and he is on standby, and I hope that we will not have any issues with his presentation. So don't go away, folks. Come back in a couple of minutes, and Richard will be here, and he will talk about community engagement, which is a very important topic. So thank you so much, Jamil. Thank you for your time and your effort.
Thank you.